People a chance to process the information. I want to do a little bit of sorting here. Can we agree? Is the first one unmagnetized? All right. Now, if you used a paragraph format to explain this, that's fine. I'm just going to do a labeling method, okay? I would say that first one's unmagnetized. I would say this one here is a weak magnet. You see how it's starting to magnetize? The domains aren't all perfectly aligned, but it's weak. This one here is a strong magnet. And actually, this one here is also a strong magnet. It's actually the same strong magnet. Can you see it's the same one, just broken in half? Look at back here, unaligned. These guys are unaligned domains. These guys are definitely aligned domains. And maybe I'll just use that word, domains. Now the one in between, this is the middle ground. I say mostly aligned. Now realistically, you're never going to get perfect alignment. And it's not every single iron atom that's aligned. It's just a majority, right? So we're talking about this as a cartoon. It really truly is a cartoony way of talking about it. But some cartoony ways of talking about things are useful. Bohr-Rutherford diagrams were useful in their time, right? And so if you go further with electromagnetism or material sciences, you'll leave this idea probably in part at least behind, but it's a useful thing to stand on, okay? I want to think about this idea of, and I'll zoom in on it, we all probably carry these things around with us. And, maybe times are changing. Maybe it's all going to switch over to being on phones. But for now, at least my library card is like this, right? And I want to talk about how what we're talking about today actually is hidden in this library card. This library card has a black strip on it. And what a lot of people don't realize is that black strip is a magnet. It's actually not just one magnet, though. It's a whole tape of magnet. It's magnetic tape. And what we can do is have a magnetizer, and a magnetizer was just a magnet like what we're talking about here. Honestly, it's going to be an electromagnet. So I'll put a coil around it at least. And what we can do is run the current one way to make this be north, and we run it the other way and make it be south. That's all. That's how you change the polarity on an electromagnet. Run the current one way versus the other way. But as I slide this strip across the very first time, can you believe when I encode my strip, the very first time, I'm going to slide it across so that sometimes that electromagnet has north there and sometimes south, and almost like printing out binary code, it's going to be like north, north, south, south, north, south, north, south, south, north. And if, as I slid my black stripe past the magnetizer, that magnetizer flip-flopped its polarity like that. As I was sliding, I would encode that magnetic code into the strip. Now, the next time I take that strip and I slide it past an electromagnet that doesn't have any electricity running through it, I'm going to be sliding essentially a series of magnets past this electromagnetic coil. And when I slide a north or a south pole past an electromagnet, that actually produces an electrical current. If you bring a magnet close to an electromagnetic coil, it produces current in that coil. And I am getting ahead of myself because I haven't talked about current induction in this unit yet, but I'm just telling you that's how electromagnets work. You can run electricity through them to make a magnetic field, or you can bring a magnet close to them and produce electricity. It works both ways, okay? So when I take this strip and I slide it past this electromagnetic coil, basically it's just an electromagnetic reader, now I can read off that code. And every one of our cards has an encoded stripe like this, and that stripe can then be read. Your identity is wrapped up in this. Your credit card, I don't know, if you go to a hotel, you ever notice that the hotels have a whole bunch of dummy cards, and they'll slide them through an encoder, and then they'll slide them through, you will go to your hotel room door and you'll slide it through a decoder. And in the meantime, they've associated your code with the reader on the door in their system, right? Their system has that capacity. That's it. Now, half the time, your card gets messed up, probably because you rubbed it up against a magnet or against your phone or something, and you got to go back and get another one. Because with those ones at the hotel, they're not very well made. That's fine. With the ones that you have for your credit card, they actually encase this strip of a magnetic strip in a resin, and it hardens it, and it keeps those magnetic stripes from becoming unmagnetized, which is desirable, right? Because you like to not have to keep on going back to the hotel lobby with your credit card, you know? Anyway, so that's kind of a neat thing, neat technology. It essentially ends up being the equivalent of like a barcode, but made out of magnetic stripes, you know? And unlike a barcode, which you scan with a laser, an optical device, this is invisible to us. It just looks like a black strip, right? But it's the same kind of encoding, which I think is pretty cool.